All right, so we're told that vector v is equal to x comma y. So they're not giving us the actual numbers for the x component and the y component. They're just saying that the x component is going to be the variable x, and the y component is going to be the variable y. And the magnitude of vector v is going to be equal to 5. All right, I think I can digest all of that. And it says fill in the blanks to complete the following sentences. So they're saying vector w right over here. They didn't have to actually write the word vector. They have an arrow on top of the w, so we know it's a vector. So vector w is its components are 3x and 3y. So its x component is 3 times the x component of vector v, and its y component is 3 times the y component of vector v. Instead of having a y, it has a 3y. Instead of having an x, it has a 3x. So w is essentially vector v being multiplied by the scalar 3. So its magnitude is going to be 3 times the magnitude of vector v. So if vector v has a magnitude of 5, vector w is going to have a magnitude of 15. It's going to have 3 times the magnitude. All right, now they tell us vector z is equal to, so its x component is negative 2 times the x component of vector v, and its y component is negative 2 times the y component of vector v. So you could view vector z as negative 2 times vector v, or the scalar negative 2 times the vector v. And so you might say, okay, well, that means its magnitude is going to be negative 2 times the magnitude of v. But you have to remember, magnitude, that's always going to be positive. One way to think, when we talk about even absolute value, we're really thinking about the magnitude of something. We're talking about how long it is. We're not thinking about its direction. So we wouldn't think about the negative there. If we think about its direction, this negative is going to flip its direction, and we can think about that in a second. But if we just think about magnitude, we care about the 2. So it's going to have 2 times the magnitude of vector v. So instead of 5, it's going to be 5 times 2, which is 10. So now they say match each vector defined to a vector that could be its equivalent. So if we think about it, the vector with the smallest magnitude is going to be vector v. The other two we're multiplying vector v by scalars with an absolute value of more than 1. So they're going to have larger magnitudes. So the smallest magnitude is this one right over here. This is the shortest vector. So that would be our vector v. Now vector w would be one that has 3 times the magnitude, and it's going in the same direction. So this one has 3 times the magnitude. It looks like 3 times roughly, and it's definitely going in the same direction. And then vector z would have 2 times the magnitude, but since we're multiplying it times a negative scalar, it's going to go in the opposite direction. And this looks like it. This purple arrow looks like it's about twice the length of this red arrow, and it's going in the opposite direction. So I feel pretty good about what we have done here. Let's do one more of these. So let's do this one here. So here we have a vector v again. It has a magnitude of 10. And it says fill in the blanks to complete the following sentences. Vector w now. So now vector w, it's taking each of the components of vector v and multiplying them by 1/5. So you can view vector w as being equal to 1/5, the scalar 1/5 times vector v. And so the magnitude of w is going to be 1/5 the magnitude of v. So 1/5 of 10 is just going to be 2. Now vector z, it looks like it's 3/5 times vector v. We're multiplying each of the components times 3/5, so that's like multiplying the entire vector by the scalar 3/5. So its magnitude is going to be 3/5 the magnitude of vector v, and so 3/5 of 10 is 6. All right, then they say match each vector defined above to a vector that could be its equivalent. So here the vector with the largest magnitude is vector v. So this would be vector v. And the vector with the smallest magnitude is vector w. It's 1/5 the magnitude. So this has a magnitude, should be 10. This should be 1/5 of that, which is a magnitude of 2, and it looks like that. And then this should be 3/5 of the 10, which is a magnitude of 6, and that looks about right. So I feel good with what we have filled out. So hopefully that gives you a sense of how to tackle these types of example problems.